Hi, this is just an example of walking through Unit 4, Section 2. So again, first read through the scenario. After a score in a game of rugby, the team scored upon restarts the game with a drop kick to the other team. Suppose a player restarting the game drop kicks a rugby ball so that the ball's initial upward velocity is 48 feet per second. Use the formula below to write an expression for the height of the rugby ball in terms of the time after it was kicked. Note, when the ball is kicked, assume it is being kicked from ground level. The general formula for the height, h, of a projectile is a function of time. T is given by this formula. Again, where the acceleration due to gravity on the Earth equals 32 feet per second, or 9.8 meters per second squared. The v is the initial upward velocity, and h is the initial height. So again, time, as we just read, is measured in terms of seconds, right? We want to know in how many seconds. And the height is in feet. And you can use x, you can use t. Since this equation used t, I'm also going to use t. And then what it wants you to do is it wants you to substitute in what you have here. So again, I know that I have -1/2. Gravity, because we're dealing with feet, is the 32 feet per second squared. T squared. And then it's plus my initial velocity, as it's set up here in the word problem, is 48t. And it's being kicked from ground level, so the height would be 0. Again, you could simplify that however you wanted. Okay, so now moving on to the questions. In how many seconds after it was kicked will the rugby ball first be 20 feet high? Excuse me. So they want to know time, and they're telling you that the feet is 20 feet. And in order to find the seconds, so you can plot the point, you're going to have to solve a quadratic equation. So I like to choose the solver. Again, I want the height, or it's asking me when is the height 20 feet, and that equals, and then I'm just typing in my expression right here. So the 1/2, excuse me, the -1/2, 32, and you can use x, you can use t, if you want to use t squared, plus 48t. Again, that doesn't matter to add the 0. Push enter, and now you have a quadratic equation, but in order to solve it, the first thing you have to do is set it equal to 0, so you're going to subtract 20 from both sides. And then what it also did for me is it also simplified this. Half of 32 is -16. So now that I'm here, I'm going to use the quadratic formula. And the a is 16, the b is 48, the c is -20. So the opposite of b is -48. B squared, again I like to put it in parentheses, minus 4a and c, all divided by 2a. From here you can just choose simplify completely. It's plus or minus, so I'm going to separate the roots. Then I'm going to, again, if you can't see it, I'm going to click on one of the roots. I'm going to hit simplify completely, and then I'm going to click on the other root, simplify completely. So the question number 1 again was, in how many seconds after it was kicked will the rugby ball first be 20 feet high? So you look at your two answers and you recognize that 1/2 comes before 5/2, and 1/2 is actually, again, you can type in t is 1/2 or 0.5. In question 2, it says how many seconds after being kicked will the rugby ball again be 20 feet, and now we see that it is 5/2, and again you could write that as a fraction, or you could write it as a decimal, and again 20 feet high. In question 3, how high will the rugby ball be in 1 second? Now they're giving you the time. They're giving you the variable t, And so what that means is you can plug in the variable of t into your equation. So it's 1 that's being squared plus 48 times 1. Again, simplifies just like a calculator. You can do it here. And then how high will the rugby ball be after 2.25 seconds? So again, it's giving you the seconds, so that means it's giving you this column. And whenever they give you the t, that means you can substitute it right in to your expression. So 1/2, just going to drag that a little bit, times 32. Now it's 0.225 squared plus 48 times 2.25. It says, please graph, I'm going to close this right now. It says, please graph the height of the rugby ball as a function of time since it was drop kicked. So again, you're just going to plot the points. Now, if you, again, are adjusting your window appropriately, we're going from 0 seconds, maybe 10 seconds is far enough, but as we're noticing, it's already coming back down after 2 seconds, so maybe 10 is too far, because this is measuring my seconds. Maybe 5 seconds is long enough. And then how high is it going to go? Again, we notice that it has already a height of 32. You want to make sure that you're going higher than that, so possibly 50. And then you want to decide, well, what do I want to count by? From 0 to 50, maybe I want to count by 5s. And then plot your points. So 0.5 has to be somewhere in here, and we got it to be about 20 feet high. This is 2.5, and that was also 20 feet high. At 1 second, the rugby ball was about 32. And at 2.25 seconds, the rugby ball was 27. Excuse me. So now we have to just draw a curve. So we see our downward parabola. It makes sense. We kick the ball up, it reaches a point, and then we kick the ball, or the ball starts to come back down. So the question in number 5 is, what's the maximum height the rugby ball will reach? So you use your dragger, and you're looking at the maximum height, so you're trying to figure out when does it reach that height. So what is the maximum height? 36 feet is the maximum height. And when does that happen? It happens after 1.5 seconds. Again, plot that point. It's right where it crosses. Question number 6. If a player on the receiving team catches the ball on its way down, so that's this side of the graph, at a height of 4.64 feet, how long was the rugby ball in the air? So what we're doing is we're trying to figure out at a height of 4, so way down here, at 4.64. At 4.64 feet, it's been in the air for 2.9 seconds. So 4.64 feet off the ground, and it took it 2.9 seconds to get there. And then you plot your point. And question number 7, if no player on the receiving team catches the ball in the air, how many seconds after it was drop kicked will the rugby ball hit the ground? So again, representing 0 as your ground, the ground is like right there, and it takes 3 seconds for that ball to go up and for the ball to come back down. And you hit plot point in about that spot. So what you're doing for the first 3 is you're getting your minimum of 3, actually 4 points, so you can draw your curve. And then what you're doing for the last 3 questions is you're dragging the cursor back and forth to answer questions 5, 6, and 7. So you just have to be aware of, as you're looking at your equations or as you're looking at your chart, again, feet and seconds, which one represents which one. Thank you.